Hi folks, Vivek from ExamVictor here. In this video I'd like to look at how to compare fractions really quickly and efficiently. If you have any feedback or comments, do send me an email at vivek@examvictor.com. So first of all, why should we even learn this? Why should we know how to compare fractions? Of all the things to learn in the world, why is this so important? So it turns out fraction comparison is very regular and very useful in the DI section, really useful. The typical way that you'll end up using it is when you are actually trying to get the answer, and your answer would have come down to you have to compare 231 by 589 and 264 by 647, and you have to decide which of these is the lesser or more. So if you can figure out this very quickly, you would have actually got the answer. The question could be anything. It could be the number of tires exported from Indonesia. It could be the number of children graduating from 6th class to 7th class in some village. It really doesn't matter. The DI questions, they give you all kinds of random data, and the thing is what they are testing is this, if you can actually arrive at an answer very quickly. Sitting and dividing this and getting to some third place of decimal 0.143, all this doesn't matter, right? This is absolutely useless. This is not what they are testing. Now the question is, CLAT has an on-screen calculator. So many students have started asking me, sir, why should we even care, because now there is an on-screen calculator, I'll just click in that and get the answer. Honestly, nothing wrong with that, but that is a very CLAT specific approach. Second thing, it takes time. It takes time to click into that calculator. See, that calculator that is there on screen, it is available for everybody, but you can use it only with the mouse, right? You can't use the keyboard. So if it is a slightly lengthy number, or the numbers involved are more, or the calculations are like, if you have to do this maybe 5 times or 6 times for, let's say, there's some large table with lots of columns, and for each column you have to do this, then you're again going to territory where you're wasting time. So a person who knows how to do this quickly and fast and efficiently is going to get ahead of you. He will save time and he will actually get the answer faster. So all things being equal, even in CLAT where there is a calculator available, there is still some value to knowing this. Okay, there is still some value to this. In other exams anyway there is value, because whichever exam you're talking about, many of them don't have on-screen calculators. Many of them are actually still paper and pen exams, right? XAT, still paper and pen. So there is definitely value in understanding and mastering such skills. So let's see how to do it now. Alright, first let's start with some real basics. How to compare two fractions when they have the same numerator or the same denominator. Okay, let's start with the second thing first. Actually, let's start with two fractions that have the same denominator. So what I'm trying to say is that my two fractions are, let's say, P by Q and R by Q. Okay, if I have to compare these two, it's very simple. If the denominator is the same for both of them, then I just have to compare the two numerators. So if P and R, whatever relationship these two have, the same thing the fractions will also obey. So if it turns out that P is greater than R, then P by Q will be greater than R by Q. If P is less than R, then in this also the same relationship will apply. So this is a very simple case. Now let's deal with the case where the same numerator is there, denominator is different. So then the case would be, it's, let's say, P by Q and P by R. So now what happens, it's exactly the opposite. It's exactly the opposite. What happens is you compare Q and R in this case. So Q and R, whatever relationship they have, the exact opposite relationship the fractions will have. So if Q is, let's say, greater than R, then P by Q will be less than P by R. Okay, and if Q is less than R, then the exact opposite thing will happen here. So this would be greater than. I'll show you this with an example what I mean. So let's say if this is 2 by 15 and this is 2 by 17. Now you can understand, right? 2 by 15 is obviously a greater number than 2 by 17. Even though 15 is greater than 17, so 2 by 15, since 15 is greater than 17, 2 by 15 is less than 2 by 17. Take an example for this where the denominator is the same example let's take. So 2 by 15 and 6 by 15. Okay, so now I have to compare the numerators. So 2 is greater than 6, 2 greater than 6, right? So 2 by 15 is greater than 6 by 15. So this was a basic example. If you have the same numerator or same denominator, then you're very lucky. Honestly, you will not see such a simple thing in most of the MBA exams, but still we should know this basic to actually move to the next step. Right, now this is also another fairly specific example, but still at least somewhat more helpful to know what happens when the same number is added to the numerator and the denominator. So let's see what I'm trying to explain with an example here. Let's say that we start with a fraction p by q. Alright, so we started with this, and somehow through whatever reason, maybe the question had it for whatever reason, we end up wanting to calculate or compare p by q with p plus x by q plus x. Right, we want to compare these two. We don't know why. I mean, the question might have something that requires you to do it, but finally you want to compare these two, and you're wondering what should come inside this box. So actually this divides into two alternatives. If p by q, if this is a proper fraction, then p by q will be actually less than p plus x by q plus x. If this is an improper fraction, then p by q turns out to be greater than p plus x by q plus x. This is what you need to remember. Okay. Now, what is a proper fraction? What is an improper fraction? There is a video on that. Look at the fraction basics video. This will make it clear. Proper fractions are basically the numerator is smaller than the denominator. Improper fractions, numerator is greater than the denominator. So depending on if it's a proper fraction or an improper fraction, this is how this rule works out. Let's look at an example. Alright. Let's look at an example. Let's say p by q is 234 by 489. I'm just making these numbers up, anything. And let's say the amount x that we added, let's say it is 100. Okay, let's say x is 100. So that means we are comparing 234 by 489 with 334 by 589, right? So now we want to know the relationship between 234 by 489 and 334 by 589. By what we just now studied, we should say that 234 by 489 should be less than 334 by 589, right? And this is actually true. You can calculate it and see if you want to. So this is how it works. This is what the rule means. Why does this work? If you are interested in knowing why it works, this is just I mean, it can be proved very exhaustively, but if you want to understand at an intuitive level, what is happening is that if you think about it, the value of the fraction, as you keep adding the same number to the numerator and denominator, it's getting closer and closer to 1. Okay, this actually is called asymptotically tending to 1. Doesn't matter, not important, you don't have to know this. This is just for your information. This thing is called asymptotically tending to 1, and the value of this fraction, as you keep adding larger and larger x, it will keep getting closer and closer to 1. It will never reach 1. So that's all this applies for this branch when it is a proper fraction. Okay, if it's an improper fraction, it's almost the exact opposite, and you know that it should be the other way around, right? So if p by q, you add something to the numerator and denominator, then p by q will be greater than p plus x by q plus x. This rule is also, again, I won't say it's super useful because you won't find too many answers where this is exactly happening. If it does happen, great, you know how to do it. But even this is also not so common. We should just know this because it's good to know. So now, having studied all this, are we any closer to being able to compare any two fractions in the world? Probably not. So let's look at the most general case. Let's say that there is a fraction p by q. There is another fraction x by y, and I want to compare them. I want to know what to put inside this box. Well, the rule that most people say is p into y, and you put a box here and you say x into q, and whatever you get put in this box, the same thing will happen in this box. So basically you cross multiply and you write py and qx, right? So py qx, and you find out the values of these two, and whatever relationship applies here, whether it's less than, greater than, the same relationship will apply here also. But does this make our life much simpler? Does it really help us? Honestly, in my experience, not too much, because this multiplication also may be complicated, right? it could be that these are some fairly random 3-digit numbers. So multiplying them is also not going to be much simpler. It doesn't make our life much easier. So then what are we supposed to do really? How do we get ahead of this struggle and actually try to compare these fractions? That's what I'll show you on the next page. So when things get really down and dirty, what do you do? How do you finally evaluate these really horrible fractions and make them something that you can compare? Honestly, the useful practical tip that I found is to really just make quick and dirty approximations. The thing is, you are not looking for some third decimal level accuracy, right? Because you are at the end of the day interested in comparing the fractions. All you want to know is if I can put a greater than or a less than sign. So that's where really the approximations come in handy. Things that you can look for first of all is the fraction more or less than half. Okay, this is easy to guess, right? Let's say our fraction that we're talking about is some random 284 by 589. Let's just say. Okay, so now by looking at it, you should develop the ability to say, is this more or less than half? How do I do it? How do I think about it? I look at the denominator 589. Okay, so it's close to 590. 590. I brought it to the nearest 10 at least, because if you bring it to the nearest 10, then it's easier to half and it's easier to do other things, right? So bring it to 590. Now I know that half of 500 is 250. I know half of 90 is 45. So I know that 250 plus 45, 295 is the half of this. So this is very close. I don't care. I'll stay at 295. I look at 284. I'll say, okay, 284 is less than 295. So I'm expecting overall this fraction to be less than half. Okay. So far, if this itself is enough for me, then great. I've already answered the question. I can move on. If it's not enough, then what do I do? Let's say I actually want to arrive at the value of this. For whatever reason, I really need to know what is the value of this. Okay. So 284, I can make it, if I'm interested in a very dirty approximation, I'll say actually that this is 284 is actually 300. I'll say 589 is 600. Okay. 300 by 600. Now this is easy. This is 0.5. I know that I have made an approximation. I have increased the denominator also. I have increased the numerator also. I know that my original fraction was less than half. So I know that the answer is very near half, but it is on the lesser side of half. So I'll say, okay, maybe it's 0.49. What is the actual value? If I punch it into a calculator, then this is 0.482. Okay. Now, this is how you make an approximate calculation. The steps are really one, you round. Okay. You round the numerator and the denominator. While rounding, you actually have to, of course, make it easy for yourself to calculate, but you have to keep in mind that you have to remember what you're doing. You have to remember if I have rounded up or rounded down. See, if you round up the denominator, then you are actually reducing the value because you're increasing the denominator. So you keep in mind that the answer that you would get after rounding would be less than the actual answer. So these are just things to keep in mind that you will get with more practice. Let's look at another example on the next page. Okay, so how about another example? Let's cook up another two random numbers. Let's maybe look at 746 by 983. How would you very quickly and dirtily, how would you approximate this? Like we discussed, first thing we should check is how does it lie with respect to 0.5. So you can look at this. This is something like 750 by almost 1000, right? The numerator is almost 750 and the denominator is almost 1000. So in fact, this is the way that we'll even move forward. First thing we can see is that this is more than 0.5. Second thing we can see is that approximately if I divide these two, I get 0.75. So this is a number that I'm comfortable using for calculations. While doing this, what we should notice is we have increased the numerator also and we have increased the denominator also. Numerator we increased by plus 4, this by plus 17. So what does that tell us? Should the actual value, should it be more than 0.75 or less than 0.75? Since we have increased the denominator more and the numerator less, so our gut feel or our instinct should tell us that the actual value, it should be slightly more than 0.75. Now let's put it to the calculator and see what we actually get. The value of this fraction, if I punch it in, it comes out to be 0.7589. So first thing is our approximation is really good because the first two digits are the same. Second thing is that it's slightly more than 0.75. So this is also correct. So this is another example of us following the same steps. first check where it lies with respect to half. Alright. Second thing is, keep notice or keep track of how much you increase the numerator and how much you increase the denominator. And then from that you should be able to estimate if your final answer is going to be slightly less or slightly more than the actual value. Okay, before we wrap up this video, I would like to clarify one common misconception, something that I have noticed in many of students that I have spoken to over the years. This is a trick that is taught in many coaching academies also. So people come to me having this funda wrong. But this is actually very important. The trick that they teach is that you should calculate the numerator denominator difference. You should find out the difference between the numerator and the denominator, and you should do this for both your fractions. And if the difference is more, that means the fraction is also larger. So these tricks are actually wrong and they are misleading. I'll show you why. Take a very simple example. Take 2 by 3, 20 by 30. See, obviously 20 by 30 is also just 2 by 3 only. But if you use this rule or this trick, then you can see that 3 minus 2 is 1, 30 minus 20 is 10. So they will tell you that 20 by 30 is less than 2 by 3. Is less than 2 by 3. But this is not the case at all. It's actually the same. So this rule cannot be applied blindly. It has a number of riders, it has a number of conditions before you can apply it. See, I don't think there is any value in memorizing all those conditions and then finding out if this specific case that you need to compare obeys all those conditions, and so you can apply this trick. See, that is actually opposite to the utility of a trick. A trick is something that saves you time, not actually makes you spend more time. So my advice to you would be to not use this trick at all, because it has a number of conditions that have to come true before it can be used. So in an exam you're not going to have time to sit and start evaluating those conditions, remembering them first, evaluating them, then applying this. My advice to you for comparing fractions is really to practice more, practice quick approximations more, and that itself will give you the answer 99% of the time. For that remaining 1%, either you hand calculate or you use the on-screen calculator. That would be faster. This is Vivek. Thanks for watching.